the formula, you had to evaluate each expression for those given values of A, B, and C. So let's see. Table 8. What would, you could either tell me the final answer or tell me what it looks like plugged in. The final answer is -5. Okay. Anyone else at that table want to chime in? Okay, or +5. Class, what do we think? And why the +5? So anytime you guys plug stuff in, what do I always tell you to use? So table 1, how about you guys tell me? Anytime you guys plug stuff in, I always tell you to use what? Parentheses. So if it's -b and my b happens to be a -5, plugged in, it looks like that. And what happens with that double negative? Becomes a positive. Because really, what's always outside parentheses, even if it's not written? By what? Multiplication by what? A 1. So since there's a minus there, that means it's a -1 times -5. So I should get a +5 for that one. All right. Let's see. Table 2. Can you tell me either the final answer or what it looks like? Okay. Anyone disagree with that? All agree that it's 25.
Yes.
Anyone think it's -25? So if you use your calculator and it said -25, that is because you did not put the parentheses. So don't forget those. It does change your answer because the calculator can only read what you put into it. So if you don't put the parentheses, like I'm showing you now, -5 squared, it reads it as exponents first and then times the -1. So that's why you have to put the parentheses to show we want the -5 to be squared, and then it'll give you the right answer. So that's why I've been stressing that all year. It's for these problems. So yes, it has to be a +25 for number 2. Good. Okay, so then table 3, table 3, I want you to read to me how it looks plugged in.
So can we do -5 in parentheses, then squared, -4, then 9 squared. I mean, a 9 in parentheses, then -4.
Okay, perfect. Don't skip the plugging in step. That is so important. Do you guys also remember yesterday we talked about b squared minus 4ac? It has a special name. Do you guys remember what it was? No, it's in the quadratic formula, but that specific part has a special name. We learned it yesterday and we had to write it down. Tell me what the word maybe sounds like. Something. It does start with a D. Discriminant. Okay, you'll hear that a lot, like you'll hear it in your higher level math too. So if I say, oh, what'd you get for the discriminant? I'm talking about what'd you get for b squared minus 4ac. So that would go under the square root symbol. And the reason why it has a special name is because if you calculate the discriminant right off the bat, you can see if it has 1, 2, or no solutions. Because of it's either square root of a negative, positive, or 0. So that's why we even care. I would suggest once you plugged it in, use a calculator. At this level of math, it's fine for you to use a calculator. We've practiced it by hand a few times, which is good to practice. But it's like when you guys still do long division, it drives me crazy. Put it in your calculator. So you should have gotten 97 for that one. If you didn't, maybe you forgot to put parentheses right here. That would change your answer. So you have to put parentheses when you plug stuff in. And now it gives you the right answer. Good on number 3. So if my discriminant is 97, how many solutions would that quadratic have? 2, because anytime it's a positive number, you'll still have 2 solutions. Even though 97 is not a perfect square, you'll still have 2 solutions. All right, last one, table 4, can you either tell me your final answer or tell me what it looks like plugged in? All right, so we're plugging in for the B and the A. They're defined up here. And what else is that? Let me get the world. Okay, so I like this half of it. This half is good. I mean, technically, I've been telling you to use parentheses, so you use the parentheses, but yeah, you do need parentheses on the -5. Now, is this B, because that's what B is this B being squared to number 4?
No.
So I'm gonna erase the square part. And then, is it good now?
No.
What is it missing? A negative outside the parentheses, because it's negative B, so if you plug in a negative, what happens? It will become a positive, and then plus or minus the square root of 9, is 9 a perfect square?
Yeah.
Yes, the square root of 9. And the plus or minus is already in the quadratic formula, so that's nice, you don't have to like worry about forgetting it, because it's in the formula. And then you just need to solve for both cases. So what's 5 plus 3? And then what's 5 minus 3? All right, and I wrote it like this. This kind of just shows you that it's like X could be either of those numbers. It's not a coordinate. It's just telling you X could be 8 or 2. Yes. Okay, questions on the warm-up? Yes.
I just can't get on this. How does that equal -7?
Because, well, we could do it by hand too. First thing I'm gonna tell you, because I put it in my calculator the way it looks on the paper, and that's what it for me. Second, it's order of operation. So would you do exponent, subtraction, or multiplying first? What's -5 squared? 5. Positive 25, remember we went over that in the second one, it should be positive. And then, what's -4 times 9? 32.
Oh, 36.
So -36, and then -36 times -2 is. Everyone else listening? What's -36 times -2? Okay, I'm still gonna do it. Good, I'm glad you found it. Let's still finish it. What's negative 36 times negative 2? And then add those together, we get 97. Good. Any other questions? These are good questions. All right, the quadratic formula has a lot of steps, so if you miss even one step, kind of messes up the whole thing. Table 4. All right, here's what we're gonna do today. It really shouldn't be a long lesson. My classes so far have had time to work, but it really kills me how like I give you time to work and I see like a handful of people playing games on their computer, watching YouTube, or maybe like staring at their phone. Like we can make it to where like, there's just no electronics even during independent time. Like we could do that. But also when I see that, I'm like, okay, this person really just doesn't care about their grade. So, and I do this every year. When I look at my grades and maybe like there's a kid that's close to the next letter grade, I look at their performance and I look at like, did they try? Like, were they playing games? Were they on their phone? Like, were they just not doing the work? And then I don't bump those kids. Like, I don't care if you're like 0.5 away from the next letter grade. I will leave you at the grade that you're at if I think that you had like could have done more on your end. Okay, but if the kid worked hard, if they came to tutoring, if they ask me questions and they're just like that little bit away, then I do bump those kids. So really like consider that. Plus on a side note, a little bit unrelated, but I've been like gathering teacher evaluations for everyone that's trying out for my team next year. And it is wild. Teachers that have had these kids like maybe last year or the year before, they remember like every little bad thing that someone did. Like, think about that. When you put references down on a job application or something, people remember like if you were a great kid or if you were like not caring at all. So just consider that. It was wild all the emails I got when I asked for feedback on a handful of students. So just consider that. All right, moving on though. Today's lesson is also about the quadratic formula, and we are identifying some errors. So we've gone over the steps previously. If you need to review them, you can find them in your notes. But these equations are worked out, and each one of them has a mistake. Try to find where the mistake was made and how to fix that mistake. Okay, so try that with just the first two equations right now, and then I'll check in, go over them. It'll be pretty short one. Okay, so just checking in. I don't necessarily want to know the final answer yet about where the error is, but let's review those steps. And these, as you can see, are all being solved by quadratic formula. So for solving by quadratic formula in equation 1, am I able to solve it the way that it is right now?
Yeah.
Okay, some are saying yes.
Oh, no.
I say no. Okay, why no? It's not equal to 0. So very first step in solving by the quadratic formula is you need to set the equation equal to 0. How you do that will just depend. How can I make 8x 0? Subtract it. And whatever you do on one side, you have to do to the other side. So there's no like terms with that x term. I mean, there's an x squared, but that's not what a like term is. Like terms have the same exact variable with the same exact exponents. So then my new standard form of it is 2x squared minus 8x plus 3 equals 0. And it's minus because that's what we had to do to move it. Okay. So did they, after you set it equal to 0, Did they identify their A, B, and C the right way?
Yes.
Yeah. All right, I would say so. So that would be your second step, is making sure we identify A, B, and C. And it looks good. So they didn't show that they subtracted from each side, but that's what you would have to do. And that's why it's -8. So far, so good. Step 3 would be to do what?
What?
Well, we did that already when we set it equal to 0, so that'll be included for when we set it equal to 0. After we know what A, B, and C are, we can plug them into the formula. Am I making you memorize that formula?
Yeah, no.
I am not. I'm not making you memorize it. That's what it is. Plug it in, make sure you use parentheses. Did they plug it in the right way?
Yes.
So let's see, -b, b squared minus 4ac over 2a. Looks good to me. And they have parentheses in all the right spots. Did they simplify or at least start simplifying correctly?
Yes.
Yeah, so that double negative made it a positive. -8 squared is what? So good, that's there. What's 4 times 2 times 3? And they have 24 here too, so that's good. Is 64 minus 24 40?
Yes.
So this stuff looks good. They also did the 2 times 2, which is 4. Now from here, this might be where honestly you guys probably struggle too, because of that irrational solution. So step 4 is to simplify. Is the square root of 40 a perfect square?
No.
It is not. It is not a perfect square. Because when I look at the calculator, square root of 40 gives me a long decimal, so it's not a perfect square. In that case, we do have to simplify the radical. That was that add-in lesson that I gave you guys on the sub day. So if you're like, what? Let's not go back and watch that video that you were supposed to. But you simplify the radical by breaking it down to its prime factors. So what are 2 numbers that multiply to 40? Are they both prime?
No.
So prime means it can't be broken down anymore. So both of these can be. What does 10 break into? Are these both prime?
Yeah.
Yes, because they don't break down further except for one in itself. Is 4 prime?
No.
It breaks into. Okay, good. Now only look at the prime numbers. I'm even going to cross out these ones so you don't get confused. Remember, I wanted you to imagine this as like a jail cell. In order to escape the jail, you need a pair of the same number. So like I have a pair of 2s here. For each pair, you write it once, and will it go inside or outside? Outside, because it escaped. Any leftovers go where? Inside. And if there's multiple, you multiply them, right? Multiple, you multiply. So what's 5 times 2?
Sure.
Okay, so from here, because it looks like they kind of skipped some steps too. So from here, to simplify that radical, it would be 8 plus or minus 2 radical 10 over 4. Now, once you've done that, so all we did is simplify the radical. You see if this fraction can simplify at all. So kind of imagine that 2 radical 10. That radical 10 won't be changed anymore. It's almost like having a 2x there. So just treat that kind of like you would a variable. But looking at like the constants and the coefficients, if you will, is there a common factor between 8, 2, and 4?
Yeah.
Two divides evenly into all of them. So you really should reduce that. What's 8 divided by 2? 2 divided by 2? 1, so that'll cancel. 4 divided by 2. So it looks like where they messed it up was in between this step, because that is not my answer. Okay, my answer is this. It's gonna be 4 plus or minus radical 10 over 2. And that's it. Questions on that? I will say, like, I've looked at your tests. I don't think it's very hard. I like that. But that is the step. You simplify, make sure your radicals are simplified. If there's like a common factor, factor it out. Yeah, but there you go. Questions on that? Okay, so that was kind of a longer one, but if you're highlighting where the mistake took place, it was like here. Now, moving on. In equation 2, can someone raise their hand and I'll try to show favoritism to those that haven't spoken a lot. Who thinks they found the mistake in equation 2? Wrigley? They didn't set it equal to 0, so what would I have to do to make that 10 0? And whatever you do on one side. So then my standard form should be this, x squared plus 3x minus 10 equals 0. So then in identifying my A, B, and C, is that right?
No.
It's wrong for which one? The C. So, I mean, you could highlight, I suppose, from here to there. Like in the first one, they didn't show them setting it equal to 0, but they still got the A, B, and C right. In this one, they probably did not set it equal to 0 because they got the C wrong. So that highlights the mistake. The C should be -10 because of that. All right, the rest of it, I mean, obviously, since they put a 10, that would mess up the rest of it. But as far as I can see, that seems to be the only mistake. But a lot of silly mistakes usually get made when you forget those parentheses. So always put those too. Did anyone fully solve it and get like the final answers? Okay, I'm not that concerned about it today. I'll show you how you can find it quickly. We're just finding the errors today. So now if you have it, look at equation 3 and 4. For those errors, they find them, circle them. The very first spot that you see an error is usually what you would identify like on the test. So equation 3, raise your hand. Where do you think the mistake was made? Jalen? Right here, right down here? Yeah. Okay, like this part of it? Or like that whole part? Okay, what do you not like about it? Okay, so -2 squared is a +4. And then 4 times, or -4 times 9 is what? Class. -36. And then -36 times -1 is a +36. So I would say that they did that part right. Anything, raise your hand if you think you found a mistake. Really? They didn't simplify. So let's see, because I remember 40 was 2 radical 10. So yeah, if they simplify, 2 comes out of all of them. It becomes 1 plus or minus radical 10. But I will say that's not where the mistake, I mean, they did simplify incorrectly, but that's not where the mistake is. The first mistake at least. Brian?
There's a first mistake, like, on the second step of the bottom.
Like here?
Yeah.
So what should the bottom be?
18.
Should be 18 because the bottom's supposed to be 2 times A, and in this one, A is 9. So yeah, they did this part okay. There's some things that I would change. Like I would use parentheses, but like the top part isn't where they made a mistake, but I'm just telling you that's how you can avoid like silly mistakes. It's the bottom part where they forgot to do the 2 times A. And so yeah, it should be 18 under there when you start simplifying. So that's where the first mistake was made. Questions on that? And then of course, because they made a mistake on the bottom, that would affect the simplifying. So there would actually be 18 on the bottom and yeah. I'll show you how to find the answer. All right, but questions on equation 3? All right, what about equation 4? Where do you think the mistake was made? Brian?
On the third step, it's a negative equation.
Right here.
No,
Oh, right here. So they did something wrong from here to there because what's negative 10 squared? A positive 100. So there's a mistake. I don't recall that being the first mistake. Maybe I'm wrong. Or maybe there's one more mistake. Did anyone find another mistake in that one? Brian? So when you plug in the negative 10, so B is a negative 10, you're plugging it into negative B. So that's why, again, I say use parentheses, don't skip that step, even though it seems silly, like you could probably do that in your head. Because what happens to that double negative? And they kept it as negative the entire time, which would change their final, it would change your answer. So they made 2 mistakes. All in this middle step is where they made the mistakes, which of course affected everything. So yeah, I would say the first time where you see the mistake made, it's going to be like if that was the question on the test, what step was the mistake, you would say it's that step. But yeah, questions on this exercise? Really great way to prepare for a test. We won't necessarily answer every single question on the back, but I do want to show you. You could always check all your answers by doing what? Putting it into Desmos, even the ones that are irrational. So I'll show you. So for equation 1, I'm just going to type it in exactly how it looks on my paper. I'm not even going to set it equal to 0, although if I did set it equal to 0, it would have a nicer looking U shape. This one, when I don't set it equal to 0, it just looks like 2 straight lines. But let's look at its solutions. Obviously, that doesn't really look like the solution I have because this is in decimal form. But if I calculate that decimal, which we practiced that yesterday, so it would be 4 plus the square root of 10 over 2. Does that match one of these? Yes, no?
Yeah.
It does. It matches the one that's on the right. Like it has the same decimal. I mean, it is rounded on the graph. That's why we leave our answer in radical form. If I show you the negative, stop talking. That matches the other one. So Doesn't really help you if it's an open response question and your answer is irrational, because I wouldn't accept these decimals. But if you have a multiple choice and you want to test your answers to see which one matches the graph, that could be a strategy. Like if you don't know what to do, test your answers, see which one gives you the decimals equivalent to the zeros on here. That makes sense? Good. So you could always check for every single method your zeros on Desmos. So let me show you equation 2 real quick. That one I know had nice answers, so that's why I want to show you that one. X squared plus 3x equals 10. Those zeros are -5 and +2. So if you want to write that for equation 2, you can. It does have solutions. It's -5 and +2. The other two were irrational, so doesn't really help you unless you're testing an answer to compare it to. But that's just one more way you could make sure you're doing it right on a test. Questions on that? Okay, that's really all I wanted to show you today. So you have a good chunk of time. Don't waste it, because tomorrow we're doing binder checks and a short lesson. So the puzzle pieces that you should be working on, 7.03 to 7.18 study guides are posted, and binder checks. When are we testing for unit 7? Tuesday next week. So I recommend this Saturday is Saturday Academy, one of the last ones of the semester. Go to Saturday Academy and get help on your study guides primarily.